We'll continue to talk about algorithms and flowcharts. So the first thing we'll do is recap what we have learned about flowcharts. So here's the picture. You remember the symbol for a start and end, very similar, or the same symbol. I just drew it in a way that's not exactly the same, but that's the idea. And this is the rectangle for an action or an instruction. This shape is used for print. The diamond shape is used for a question, a yes or no question, and the arrows coming out of the diamond according to what the answer is, and a circle is a connector. So now let's go and see some kind of problem, and we'll see how we solve the problem with drawing a flowchart. So the problem has to do with 9 white balls. 8 of them weigh the same and 1 is heavier, but we don't know which one is heavier because they all look the same. So for our assistance we have a balancing scale. What is a balancing scale? A balancing scale is a scale that doesn't show weight, but it looks like this. It's probably better if I draw it. It looks like this, and it has sort of a bucket here and another bucket on the other side, and you can put things into the bucket, and the scale is sort of hanging. So if one side is heavier, if let's say the right side is heavier, it will pull down. If the left side is heavier, the left side will pull down, and if they are the same, they will stay the way they are right now, which is balanced. So this is called a balancing scale. So all we can do is we can put balls here, we can put balls here, and we can see which side is heavier or if they are equal. So let's think about the problem a little bit. We have 1, 2, etc. up to 9. Let's say this ball will be ball number 1, ball number 2, etc. up to ball number 9. So if let's say we take ball number 1 and put it here, and put ball number 2 and put it here, and then we activate the scale, we'll see if this one pulls down, that means 2 is heavier than 1. If this one pulls down, that means 1 is heavier than 2. If they remain equal, then 1 and 2 weigh the same, and we have to search the rest of the balls for the heavier one. Now we only have 2 times that we can put things on a scale, so this is a little bit of a problem. If we divide it this way, we will not finish, because the next time if we pick for example number 3 and number 4, and by weighing them we'll determine if one of them is heavier or not. If they are not, then we still have 5, 6, 7, 8, 9, and we ran out of weighing. We can't weigh anymore because we are only allowed 2 times to put it on the scale. So let's think of another method. And usually when you solve an algorithm, the first thing you have to do is think. And think and think and think and think again. Because it's not going to come out of just doing other things. You just have to think in your head what to do. We have 9 balls, so let's have another thought. Let's divide the balls into 4 and 4. So we have 1 through 4, and then we have 5 through 8. So if we put 1 through 4 on one side and we put 5 through 8 on the other side, and if the scale remains balanced, that means 9 is the heavier one, right? Because the question tells us that one of them is heavier than the rest. But what do we do if, let's say, the left side pulls down? If the left side pulls down, we know that the heavier one is here, between 1 and 4. And if the right side pulls down, then we know that the heavier one is over here, between 5 and 8. So let's suppose that the left side pulled down. So now we have 1 through 4. We know 1 out of 4 is the heavier. It's either 1, 2, 3, or 4. Any of them can be the heavier because the whole side pulled down. So now if you take 1 and 2, put it on one side, 3 and 4, put it on the other side, and let's suppose this side pulls down. Then, first of all, we finished the number of times that we can put on a scale, because this is the second weighing. And that means 1 out of 1 and 2 are heavier. If this one pulls down, then 1 out of 3 and 4. But we still didn't get the answer. So we used the 2 times that we had for the scale, and we still didn't get the answer. So in this case, instead of giving you more suggestions, I'll go right to the answer, because we actually want to demonstrate how to use the flowchart to solve it. But the solution itself is quite simple if you think about it a little bit. What you have to do is you have to divide the balls into 3 groups, and the groups will be 3, 3, 3. 1, 2, 3, 4, 5, 6, and 7, 8, 9. And then if you weigh, for example, 1, 2, 3 against 4, 5, 6, and then you see that they are still balanced, then the heavier ball is in the group of 7, 8, 9, and then from 7, 8, 9 you just take 2 of them. Let's say you take 7 and you take 9, and you put them on the scale, and if one of them is heavier, we already know what it is. If they are equal, then 8 is the heavier. And the same thing we'll do with the other groups. If 1, 2, 3 pull down, then we take 1 and 2, put them on the scale, and then we know whether 1, 2, or 3 is the heavier. And the same thing goes for the group of the 4, 5, and 6. So again, the method is to divide them into groups of 3. And we have 3 groups of 3. We have 1, 2, 3, 4, 5, and 6. And the last group is 7, 8, and 9. And we weigh this against that. And as I said before, if this side is heavier, we weigh this group, 1 and 2, or 1 and 3. If this group is heavier, we weigh 1, 2 of those. And if those are balanced, then we take this group and we do the same thing here. So I'll let you think about it a little bit on how to construct a flowchart that will solve this problem. And in the next video, I will send the solution with a flowchart. But for right now, I just hope that you got the method of this algorithm, and this will be enough for now.